Look at this function over here. It looks pretty messy, and all we're asked to find is the number of solutions of f of x equals 0. So we're finding the number of roots in the real number set. So let's try to take a look at this. The first thing that you might notice is that this numerator part and this numerator part are the exact same, so we can factor that out. The same thing with this component of the denominator, right? So let's actually do that. And what do we get when we do that? We can write f of x equals sine of x plus 2 times this large part, x to the 2023 plus 2024x plus 2025. So that's the numerator, and the denominator is just going to be what's in common with both of these. So that's e to the pi x times x squared minus x plus 3. And if you think about it, sine of x plus 2, can that ever give us 0? For that to be the case, you'd have to have sine of x equaling -2, which is never possible. So we really don't care about that. Same thing with the denominator, e to the pi x, no matter what x is, that's never going to, the f of x is never going to become 0 because of anything in the denominator. One thing that might be interesting is to see if the roots of this might impede with the roots of x to the 2023 plus 2024x plus 2025. But this has, I think, irrational roots, right? It'll be, let's see, yeah, this will have complex roots because the discriminant is, I think, like b squared minus 4ac. So it's like -11 or something. So we don't need to worry about that. Let's take a look at this numerator then, right? X to the 2023 plus 2024x plus 2025. You'll notice that the numbers are very close to one another. So one root that you might see is x equals -1, right? Because 2024x plus 2025, when you have -1, that's just going to be +1, negative 2024 plus 2025, and then -1 to the 2023 is -1. So we're done. This is one root, but what about the other roots? We definitely can't find them, but how do we know if any of them are real or not? Let's take the derivative of this, right? So this is f of x, and you'll see why we're doing this, right? We know that there is one root, but what about the other roots? So if we take f prime of x, we're going to get 2023 x to the 2022nd plus 2024. Okay, what does this tell us? For all real numbers, x f of x is increasing. Or actually, I should be a bit more thorough. For all real numbers, f of x is greater than 0, right? Because 2024 is obviously greater than 0, and any number that you put in, x to the 2022nd is going to be, it's a square, right? It's an even exponent, so that is always going to be positive or 0. And so if f prime of x is always greater than 0, f of x is always increasing. If that's the case, we know there's one root. There can never be a root after -1, nor can there ever be a root before -1, right? Like if we just draw a little schematic, I guess, or like we'll just draw it out somehow. There's a root here at -1, but it's always increasing after that, right? Like let's say something like that. It's never going to touch the origin again, right? It's never going to have another root. Same thing before that. It's been increasing to get here. It's not like it went above and then came down and came back up. It's always been increasing, right? Obviously, it doesn't actually look like this. I'm guessing at least, but this is the only root there can be. And so they didn't. Now let's see what they asked us for. They asked us for the number of solutions. They didn't ask us for the actual solution. So for this, we just put 1, and with that, we're done. I think this will also give you like +3 points on the exam. So it's a pretty quick question, and it's worth, oh no, not even +3. I think it's +4. You can check that on the paper yourself. But that's, hope you enjoyed this video. Hope you learned something new. If you enjoyed it, make sure to give it a thumbs up, give it a like. And if you want to see more videos like this, please do consider subscribing as well. Thanks so much for watching, and I'll see you in the next video.